Let's review some basic facts. Angles can be measured in degrees or in radians. And the basic equivalent that you should remember, the basic equivalence, is that 180 degrees is the same as pi radians. So let's work from that. We can double 180, 360 degrees. Doubling pi gives you 2 pi. So 2 pi radians, 360 degrees. We could half 180. Half of pi is written as pi upon 2. Of course, it could be written as half pi, but we prefer writing pi upon 2, and that's how you read it. We could do a half of 90, get 45. Half of pi upon 2 would be pi upon 4. 4 lots of 45 make up 180. We could divide 180 by 3. 360s, 180, pi upon 3. We could half the 60 to get 30. Half of pi upon 3, pi upon 6. 6 lots of 30, 180. So these are some of the basic equivalences between degrees and radians. Next, we'll look at some exact values for sine, cos, and tan. Two diagrams are used: equilateral triangle and a square, and in each case we half them. This produces right-angled triangles. Lengths of sides we need to put in. If we say that this, because we've halved one of the sides and we don't want to end up with fractions, we'll call each side length 2. So this would then become a half of this 2, which is 1. Pythagoras, 2 squared minus 1 squared, 4 minus 1 is 3, square rooted. In this case, each side we'll call length 1, and 1 squared plus 1 squared square rooted square root of 2. Angles, we're talking radians now. Pi radians, 180 degrees, is the sum of the 3 angles in this equilateral triangle. So pi upon 3 for each of these 3 angles. So this is pi upon 3. Of course, up here we've chopped it in half. A half of pi upon 3 is pi upon 6. So there's our diagram. You should be able to recall this diagram very easily or very quickly, just to sketch that out so that you can get things like the sine of pi upon 6, for instance, using SOHCAHTOA, opposite 1 over hypotenuse 2. So sine of pi upon 6, 1 upon 2. That's using your memory aid, SOHCAHTOA. For instance, tan of pi upon 3, opposite over adjacent. If you're down there, opposite is root 3, adjacent is 1, so it's root 3 over 1, which just is basically root 3, and so on. Similarly here, angles of 90 degrees, so pi upon 2 for these angles. This one chopped in half would be a half of pi upon 2, that's pi upon 4. So again, things like cosine of pi upon 4 can be worked out. Adjacent over hypotenuse, 1 over root 2, and so on. So that's exact values for pi upon 3, pi upon 6, and pi upon 4 by these diagrams. You'll see them later when I do some worked examples. And the last reminder is the quadrant diagram, and how to work that quadrant diagram with radians. So there's the x-axis, and there's the y-axis. And remember, we have a line of length 1 which sits on the x-axis, and it rotates around the origin to form a circle. And if it has length 1, then the x-coordinate, suppose that's angle theta, the x-coordinate gives you the cosine of theta, and the y-coordinate gives you the sine of theta. In the first quadrant, these are both positive. In the second quadrant, there's an equivalent position over here where the numbers are the same, but the positive and negative might not be the same. Over here, the cosine is negative, the sine is positive. And remember, the tangent is always got from dividing sine by cos. So in that way, we can fill up with these letters which tell us which of cosine, sine and tan are positive. So they're all positive in the first quadrant. For angles in the second quadrant, where the cosine's negative, the sine's positive, the tan's also negative, because negative divided by positive is negative. So only the sine positive. Similar sort of reasoning goes on. Only the tan's positive for third quadrant angles. There's third quadrant angles, and only the cosine positive for fourth quadrant angles. So to get the equivalent angle in here from the first quadrant angle, we would be going pi radians minus first quad angle, and into this third quadrant, pi plus the first quad angle. And in the fourth quadrant, we would be doing 2 pi. We rotate this line all the way around to 2 pi and then backtrack. So 2 pi minus the first quad angle. That's all explained in one of my previous videos, which you should watch if you're confused about this diagram. So let's solve a trig equation. I'm going to start with this equation, root 2 sine x plus 1 equals 0. And we're going to solve it for x ranging from 0 to 2 pi. And you'll notice there is no degree sign there. So there's two clues that you're working in radians. This first one where the 2 pi appears, and the second one is that there's no degree sign there. So first move would be to try and isolate sine x. So we always balance equations. Let's take 1 away from both sides. Be root 2 sine x equals minus 1. That disappears and we take 1 away from that. Get rid of the root 2 times sine x by doing the opposite of multiplying by root 2. That's dividing both sides by root 2. This will vanish. We get sine x equals minus 1 upon root 2. So the sine is negative. X must be in, remember the quadrant diagram, sine being negative, they're all positive, the sine's positive, only the tan's positive. So the sine would be negative in the third quadrant, and also only the cosine's positive in the fourth quadrant, so the sine would be negative in the fourth quadrant. So third and fourth quadrants. So we know that this angle is in the third or fourth quadrant. So that's the first fact we can get from this. The other thing we need to know is what the first quadrant angle, because once we've got the first quadrant angle, we can then find the equivalent angles in the third and the fourth quadrant by going pi plus and 2 pi minus. So we need to find the first quadrant angle. So the first quadrant angle is, and basically we're looking for an angle whose sine is 1 upon root 2. Now the diagram that gives us a root 2 is a chopped square. So there's your square, 1 root 2. And remember, this angle of pi upon 2 radians, 90 degrees, half of pi upon 2 is pi upon 4. Now, we're sitting here, and we have to get a 1 upon root 2 for the sine. Sine of pi upon 4, 1 upon root 2. So pi upon 4 is the first quadrant angle. So we're now in a position to actually find the value of x. This is not the value of x. This is just the first quadrant angle. We need to find how far we would rotate that line all the way around to being in the third quadrant or the fourth quadrant. And as I said, pi minus for third quadrant, or 2 pi, sorry, pi plus for the third quadrant, all the way around to pi radians add the first quadrant angle, and 2 pi minus go all the way around to 2 pi and subtract. And we backtrack with the first quadrant angle. So x is equal to, for third quadrant, pi plus first quadrant angles pi upon 4, or for the fourth quadrant, all the way down to 2 pi, and then backtrack by pi upon 4. Take away pi upon 4. Now, calculating this, we think in terms of quarters of pi. There's pi upon 4. This must be 4 lots of pi upon 4. 4 quarters of pi. That's a whole 1 pi. So this is 4 lots of pi upon 4 plus 1 lot of pi upon 4. That would be 5 lots of pi upon 4. If you're not sure what I did there, I'm writing pi as 4 lots of pi upon 4. And we're adding 1 lot of pi upon 4. 4 lots of pi upon 4 plus 1 lot of pi upon 4 gives us 5 lots of pi upon 4. 5 lots of 45 degrees, basically. 2 pi, 8 lots of pi upon 4. 8 lots of pi upon 4. So 8 lots of pi upon 4 minus 1 lot of pi upon 4 would be 7 lots of pi upon 4. So 5 pi upon 4 or 7 pi upon 4. That's the solution to this equation, where x ranges from 0 up to 2 pi. So let's now solve 2 cos theta minus 1 equals 0. And again, the angle, this time theta, ranges from 0 to 2 pi. So again, we're in radians. So add 1 to both sides. Let's rearrange this. That disappears, we add 1 there. Let's divide both sides by 2 to get rid of that 2. And we've got cos theta equals a half. Cosine, positive. They're all positive, so certainly the cosine's positive, only the sine's positive, only the tan's positive, only the cosine's positive. So fourth quadrant, first quadrant are the 2 quadrants we're after. So we know that theta is in first or fourth quadrants. What's the first quadrant angle? It's the angle whose cosine is 1/2. Now the diagram we need for this one is a equilateral triangle chopped in half. Each side is 2. So this part of it would be 1, and the third side is root 3. This, remember, is pi upon 3 radians, and this would be pi upon 6 radians. So are we sitting at the pi upon 3 to get a half, or are we sitting at pi upon 6 to get a half for the cosine? Now remember, the cosine is adjacent over hypotenuse. So we want the adjacent to be 1 and the hypotenuse to be 2. So we want the 1 to be right next to us, not opposite us. So we're sitting down at pi upon 3, adjacent over hypotenuse. So pi upon 3 is the first quadrant angle. Now that's actually one of the values of theta that we want. Remember, we said the first quadrant angle was okay, so we have pi upon 3 for the value, a possible value for theta, or the fourth quadrant. Remember, we go all the way around to 2 pi and backtrack by, in this case, pi upon 3, which is the first quadrant angle. So we've got 2 pi minus pi upon 3. This time we think in thirds of pi. So 2 pi would be 6 lots of pi upon 3. 3 lots of pi upon 3 would be pi. Double that, 6 lots of pi upon 3 would be 2 pi. So this is 6 lots of pi upon 3 minus 1 lot of pi upon 3. That's 5 lots of pi upon 3. So there's our two answers. Pi upon 3 or 5 pi upon 3. Let's now solve root 3 tan y plus 1 equals 0. The range as usual between 0 and 2 pi. So first off, the rearrangement, we'll subtract 1 from both sides. This goes, and we get a minus 1. We'll divide both sides by root 3. The tangent is negative. They're all positive. Only the sine's positive, so certainly the tan will be negative in there. Only the tan's positive. Only the cosine's positive, so certainly the tan will be negative in there. So second and fourth quadrants. So y is in second or fourth quadrants. The first quad angle is, okay, so 1 upon root 3. We just ignore the minus just now because we're working in the first quadrant. The root 3 diagram comes from half of an equilateral triangle with each side 2. So that'll be 1, and this works out as root 3. And remember, this is pi upon 3, and this is pi upon 6. So are we sitting here to get a tangent of 1 upon root 3, or are we sitting up here to get a tangent of 1 upon root 3? So katoa, opposite over adjacent. Opposite has to be 1, so we must be sitting up here. Opposite over adjacent. The opposite is 1. The one right next to you is root 3. Opposite over adjacent. 1 over root 3. So it's pi upon 6. So the actual value of y is equal to second quadrant. We rotate all the way around to pi and then backtrack by the pi upon 6. So it's pi minus pi upon 6. To get the fourth quadrant, we go all the way around to 2 pi and backtrack by the pi upon 6 minus pi upon 6. So it's 2 pi minus pi upon 6. Think in terms of sixths of pi. This would be 6 lots of pi upon 6. So 6 lots of pi upon 6 minus 1 lot of pi upon 6. That's 5 lots of pi upon 6. 2 pi would be 12 lots of pi upon 6. So 12 lots of pi upon 6 minus 1 lot of pi upon 6, that's 11 lots of pi upon 6. 5 lots of pi upon 6, 11 lots of pi upon 6. That's the solution to this equation if the angle y lies between 0 and 2 pi. One last equation, tan squared a minus 1 equals 0. And again, the range for the angle is between 0 and 2 pi. So the rearrangement this time takes us to tan squared a equals 1 when we add 1 to both sides. Now this time with the squaring, opposite of squaring is square rooting, so let's take the square root of both sides. That will give us tan a equals, the square root of 1 is 1, however it could also be negative 1, so we've got to watch that we allow for a negative. You can check back, if you have negative 1 and square it, you will get 1. Tan a squared, you're back to tan squared a. So there are two possibilities, plus and minus 1. So, which quadrant is A in? Well, this time, tan can be positive or negative, so that'll occur in all 4 quadrants. Positive for tan, negative for tan, positive for tan, negative for tan. That works in all quadrants. It's either positive and negative. So tan is in all 4 quadrants. The first quadrant angle this time, well, the diagram for this is a square of side 1 with the hypotenuse being 2. This is pi upon 4, half of the pi upon 2, the right angle, half of that. And tangent of pi upon 4, opposite over adjacent. That gives us a 1. So the first quadrant angle is pi upon 4. So therefore, A is equal to, we're allowed the first quadrant angle of pi upon 4. Second quadrant would be pi minus the first quadrant angle. Third quadrant angle would be pi plus the first quadrant angle. Fourth quadrant angle all the way around to 2 pi and backtrack by pi upon 4 in this case. So 2 pi minus pi upon 4. So to work these out, let's think in quarters of pi. Pi would be 4 lots of pi upon 4. So 4 lots of pi upon 4 minus 1 lot of pi upon 4 is 3 lots of pi upon 4. This one, 4 lots of pi upon 4 plus 1 lot of pi upon 4 is 5 lots of pi upon 4. And then 2 pi, just double this, instead of 4 lots of pi upon 4, we've got 8 lots of pi upon 4. So this is 8 lots of pi upon 4 minus 1 lot of pi upon 4, that's 7 lots of pi upon 4. So there are 4 possibilities for angle A to make this equation true if A lies between 0 and 2 pi.